In this class, we are going to learn how to calculate variance and standard deviation. Okay, variance and standard deviation. Okay, but before we delve into calculation, let's talk about what is meant by variance and standard deviation. Variance refers to a statistical measure that describes the degrees of spread or dispersion in a set of data. You understand? Variance simply means variation. Are you paying attention? Variance simply means variation. So when we talk about variance, we refers to a measure, a type of measure of dispersion that is used to describe the degrees of spread or dispersion in a set of data. You understand? There are two types of variance. The first type is the population variance, and the second type is the sample variance. The sample variance is the type of variance that is used when you are working with a sample of a population. I'm going to explain, okay? When you, let's say, you have 100 people in a class, then out of the 100 people, you choose 40 as the sample. In that case, what we're going to calculate in that case is the sample variance. Are you paying attention? So sample of a population means the subset of that population. The total population is 100. Now you samples out 40. That means that if you are told to calculate that type of variance, the variance of that data set will be sample variance. Are you paying attention? Because you took subset out of the population. You took a sample out of the population. Are you paying attention? So let me give you another example. Let's assume that there are 100 students in a classroom, and we took a record of 60 students out of the 100 students for our statistical analysis. If we want to take the variance of these students, the type of variance that we are going to use is the sample variance. Are you paying attention? Because we are not working with the entire population. Do you understand? So now the reason why I'm laying emphasis on that is because if you want to calculate sample variance, the formula is different from that of population variance. Are you paying attention? Okay. So having understood what is meant by variance and the type of variance, let's quickly do some work example on sample variance. Are you paying attention? Now, sample variance, hello, we have variance here. We have sample variance, and we have the second one, the population variance. Are you paying attention? Now, let's quickly let's do some work example on sample variance. Okay. Now, sample variance is denoted by this formula, by this symbol. Okay. Sample variance is denoted by this symbol, x squared. Are you paying attention? Okay. And if you are told to calculate sample variance, you are going to use this formula. X squared is equals to summation x minus x bar all over n minus 1. I'm going to explain, okay? Don't forget that when we are dealing with, when we talk about, in our last class we discussed mean deviation, and you can see that we still have deviation here because x minus x bar means deviation. Are you paying attention? So this is the formula for sample variance. In this formula, we're going to use this formula if the value of n is not greater than 30. You understand? If the value of n is not greater than 30, we're going to make use of the formula. That is, the value of n is less than or equals to 30. Do you understand? Are you paying attention? Where n is our sample. Do you understand? So if n is less than or equals to 30, that means that we are talking about sample variance. But if it is greater than that, we are going to make use of the population variance. Are you paying attention? Okay, so this is the formula for sample variance. Okay, let's look at some work example on sample variance. Example 1. Determine the sample variance and the standard deviation of 2, 4, 8, 6, 10, 5, and 7. Okay, 2, 4, 8, 6, 5, and 7. Find the sample variance of 2, 4, 8, 6, 10, then we have 5 and 7. Now, how do we calculate the sample variance of this data? To calculate the sample variance of the data, the first step that you need to do is that you have to remember your formula. Don't forget that I told you the formula for sample variance is what? Summation x minus x bar all over n minus 1. Do you understand? Okay. Now, having known the formula, all you have to do is that you just have to, you can make use of table and you can as well calculate it directly. Okay. X are the samples that were given. You understand? So x bar is the mean of the sample. So you have to determine the mean. The mean is sum of all the sample all over the total numbers of the sample. You understand? So if I want to calculate the mean of this data now, I'm going to have, let me change this marker. X bar is equals to 2, that is sum of all the sample, 2 plus 4 plus 8 plus 6 plus 10 plus 5 and plus 7. You understand? All over the total numbers of sample, 1, 2, 3, 4, 5, 6, 7. 7. So this all over 7. Do you understand? Okay. So 2 plus 4 is 6. 6 plus 8 is 14. 14 plus 6 is 20. 20 plus 10 is what? 30. 30 plus 5 is 35. 35 plus 7 is 42. So here I'm going to have mean. The mean of this data is what? 42 all over 7. So 42 divided by 7, that will give us 6. So the mean of the population is equals to 6. Okay. So now, having gotten the mean, you can see from the formula x minus x bar. Oh, there is square here. Okay. X minus x bar squared. So we can prepare our table. Okay. We're going to have on this table, we're going to have x, then x minus x bar, then x minus x bar squared. Do you understand? Okay. So our x are the samples that were given. Okay. So here I'm going to have 2, 4, 8, 6, 10, 5, and 7. You understand? Okay. So now having written the sample, we can now take the deviation, which is x minus x bar. So for this, I'm going to have 2 minus 6. You understand? Because x bar is what? 6. So I'm going to have 2 minus 6. 2 minus 6 will give me negative 4. So I'm going to have negative 4. 4 minus 6 will give me negative 2. 8 minus 6 will give me 2. 6 minus 6 is 0. Okay. 10 minus 6 is what? 4. 5 minus 6 is what? Negative 1. Then 7 minus 6 is what? 1. Please, if you didn't understand, kindly listen to the explanation again. This is the formula for calculating sample variance. Summation x minus x bar squared all over n minus 1. Then from this formula, I discovered that I need the mean of the sample. So I calculate the mean using the formula for mean. Sum all the samples together and divide it by the count of all. Then I got this. I got the answer as 6. So having done that, I go back to the formula. I realize that I need the deviation. The deviation is the difference between the x6 that I have and the mean that I've already gotten. So I came back and prepared this table. Then I realized that from the formula, I still need the deviation squared. So I square the deviation. I'm going to square the deviation now, okay? Negative 4 squared will give me what? 16. Okay? For the sake of clarity, let us go this one. Let us go this, okay? Okay. Now, let us proceed. Here, negative 4 squared, that is negative 4 times negative 4. That is 16. Negative 2 squared, that is what? 4. 2 squared is 4. 0 squared is 0. 4 squared is 16. Negative 1 squared is 1. And this is 1. Please, do you understand what I'm doing? You see, after taking the difference, I realized that I need to square the difference according to the formula. So I squared the differences. So I got all this value. So I'm going to sum all these values together because this sign simply means summation. Are you paying attention? So now 16 plus 4 plus 4 plus 0 plus 16 plus 1 plus 1. That will give us 42. You understand? So here I'm going to have 42. 42. You understand? So when I sum all this together, I got 42. So summation x minus x bar squared is what? 42. So here I'm going to have 42 all over n minus 1. N is the total numbers of samples, and the total numbers of samples is what? 7. So I'm going to have 42 divided by 7 minus 1. Do you understand? So 42 divided by 7 minus 1 will be 42 over 6. 42 divided by 6 is what? 7. You understand? So the sample variance is 7. Now, when we got your since you have already gotten your variance, you can easily determine the standard deviation. Standard deviation is the square root of variance. Okay, so standard deviation for a sample data is given by this. We represent it by s. This is the symbol for standard deviation. S square is the symbol for sample variance. Okay, so s is equals to the square root of x squared. Okay, which is equals to square root of 7. If you take the square root of 7, square root of 7 is 2.646. Okay, 2.646. 2.646. So the standard deviation of the data that we have is 2.646. While the variance is 7. Do you understand? Okay, so I want to give you another question. You can just try this question by yourself. Determine the variance of the following data: 1 2 3 4 5 6 5 4 3 2 1. What is the variance? Okay, let me erase this. Let us erase this. So I want you to attempt that question. Then when you are done, play this video to check maybe you are correct. Do you understand? Okay, we are asked to find the sample variance and standard deviation of 1 2 3 4 5 6 5 4 3 2 1. We are asked to find the variance and the standard deviation of the data. Don't forget that the formula for variance is what? Summation x minus x bar squared all over n minus 1. You understand? So for this, I need to take the mean. You understand? I need to find the mean of this data, because according to the formula, I need the difference between the samples and the mean of the population. Mean of the samples. Difference between the samples are 1 2 3 4 and others like that, and the mean is what I want to get now. Do you understand? Okay, mean is given by this symbol. X bar equals to 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1 all over. Now count them: 1 2 3 4 5 6 7 8 9 10 11. Do you understand? Okay, now if you sum all those values together, you're going to have 36. So here I'm going to have 36 divided by 11. You see, it's just that I didn't clean this because I knew that I am still going to use it. You understand? All these values that you have here, I'm still going to use it. That's why I didn't clean it. Okay, you just have to follow the approach that we used in our previous question. In the previous example that we solved. Okay, so 36 divided by 11, that is 3.27. So here I'm going to have 3.27. That is the mean. Now, okay, I still need to we need to erase all these values as well. Okay, so let us proceed. We are going to put all the values of our x in this column. You understand? Don't forget that x are the samples that we are given. So I'm going to have here 1 2 3 4 5 6 5 4 3 2 1. Okay, now X minus X bar is the deviation, you understand? That is, I'm going to take each value of X and subtract the mean from each value, you understand? X, for example, in this case, I'm going to have 1 minus 3.127. 1 minus 3.127 is negative 2.27. So here will be negative 2.27. Then for this, I'm going to have 2 minus 3.27. Do you understand? 2 minus 3.27 is negative 1.27. Negative 1.27. Then here, I'm going to have 3, which is the X. 3 minus 3.27. That will be 0. Negative 0.27. Negative 0.27. Then here 4 minus 3.27, that will be 0.73. Okay, 0.73. 5. Okay, 5 minus 3.27, that will be 1.73. 1.73. 6 minus 3.27. Don't forget that 3.27 is the mean, so that you won't be confused that where am I getting 3.27. That is the calculated mean that we did when we start the calculation, when we start the solution. Okay, so the mean is 3.27. What I'm doing now is the deviation. Deviation is X minus X bar. Do you understand? So 5 minus 3.27 will give me 1.73. So here for this, I'm going to have 6 minus 3.27. That will be 2.73. 2.73. Okay. Okay. 5 minus 3.27. That is, no. This should be. Okay. 5 minus 3.27. That is 1.73. 1.73. 1.73. For this. 4 minus 2.27, that is 0.73. So here I'm going to have 0.73. Then for this I'm going to have negative 0.27. Then 2, that will be negative 1.27. Are you paying attention? And for 1, I'm going to have negative 2.27. Negative 2.27. Okay, so now this we need the square of the deviation, you understand? Because according to the variance formula, x squared is equal to summation x minus x bar squared. So I need to square all these values to get all these values, you understand? You see, when you are dealing with statistics, always remember your formula. Immediately you remember the formula, half of the problem is already solved. Especially when you are dealing with table. Your formula will tell you what you are going to have on your table. Okay? So here, I'm going to square all these values. Negative 2.27 squared, 5.1529. 5.1529. Negative 1.27 squared, that is 1.6129. So for this, negative 0.27, that is, if you square it, you are going to have 0.0729. So for these cells, 0.73 squared, that is 0.5329. So 1.73 squared, that is 2.9929. 2.73 squared, that is 7.4529. Okay, 1.73 squared, that is 2.9929. 2.9929. Okay, 0.73, that is 0.5329. Negative 0.27 squared, that is 0.0729. Okay, negative 1.27, that is, if you square these values, we are going to have 1.6129. Then for this, I'm going to have 5.1529. Okay, please, this calculation is simple. Okay, I just square all these values to get the deviation squared. Okay, now having gotten the square of the deviation, I still need the summation of the square. You understand? Because from the variance formula, variance is equals to summation x minus x bar squared all over n minus 1. So I'm going to sum all this together. If you sum all these values together, we are going to have 28.1819. 28.1819. Okay? So let's go back to our formula. So from this, I can easily determine the variance. X squared is the variance. X squared is equals to the sum of all these values, which is 28.1819. 28.1819 all over n minus 1. N is what? 11. You understand? So I'm going to have 11 minus 1. So here I'm going to have 28.1819 all over 10. So 28.1819 divided by 10. That will be 2.81819. Okay? So here I'm going to have 2.81819. So I can approximate it to be 2.82. Okay, that is the variance. That is the variance of the population. Now, standard deviation is the square root of variance. So now, having known that the variance is 2.81819, I'm going to take the square root of the variance to get the standard deviation. So I'm going to have square root of 2.81819. Okay, square root of 2.81819, that will give us 1.6787. 1.6787. So you can approximate to 2 decimal places. That is 1.68. Okay, that is the standard deviation and the variance that we are asked to calculate. If you get these values, that means you are correct. If you didn't get it, you have to listen and pay attention to the explanation again. You have missed it in one aspect. Okay, so that will be all for this class. Okay, in our next class we're going to talk about the population variance. Okay, and how to calculate the population variance. See you in the next class. Before you go, don't forget to like and share the video, and if you wish to be part of this channel, consider subscribing, but it is compulsory that you like the video. Okay, see you in the next class.